All right, this is a great example of one to even though you're on a time limit, you got to read and understand things. So we have a leak in the fuel tank, okay? 0 is noon, okay? And we have, it's already been leaking for an hour, probably not important. Oh, well, maybe. 11 o'clock, there were 5,000 gallons, okay? The rate at which it was is twice differentiable. This is the amount of fuel, F, is hundreds of gallons per hour. Oh, so F is actually F prime. F of T is gallons per hour. And T is hours, where you have -1, which is 11 o'clock, to 4, which is 4 p.m. So what is F prime of -0.5? And then what does that mean? Well, if this F is measured, this might be helpful to put the units on the graph. So it says that F is measured in hundreds of gallons per hour. So this is gallons per hour, hundreds, 100 gallons per hour. And this is hours since noon. I probably wouldn't write that part, but, and I would probably, wow, I don't know why that's so messy. Okay, so F prime should be gallons per hour, or gallons per hour squared. That would mean that, okay, anytime it says to interpret a derivative, I would say the y value, the y variable, is increasing, decreasing by this gallons per hour squared at negative at 11:30 a.m., comma, the measured in hundreds of the gallons per hour, so the rate of the amount of fuel. So the rate of change of fuel in the tank. So the rate of change of fuel in tank. Something to that effect. Now, how are we going to find it? We just need to approximate. Well, if all I have about F is a graph, this is F, and I want F prime, then I'm just going to approximate the slope. So how do I find the slope at -0.5? That's right here. How do I approximate this tangent line? My goal would just be to pick any 2 points near that. Well, the only points I know that are nice would be these two, so I may as well just use those two to find my slope. And so that's what they then did on the answer key. And let's see, their slope between those points. So this 0, this 0, f of 0, that's 0, -15, and -1, -20. That's just those 2 points from the line right here and here. This is -1, -20, 0, -15. And then that answer ended up should be positive. And so we'd say something along the lines of, yeah, they said the same thing I would have. This means the rate of change of fuel in the tank is, now I don't like this, changing at a rate of, I would say increasing at a rate of this per hour squared. Okay. And yeah, the 5 is in hundreds of gallons, so 500 is also acceptable. Okay. Letter B. Use a left Riemann sum to approximate the integral from -1 to 2 and interpret what that means. Well, I could tell you right away, again, what it means. Interpret an integral. Integrals are amounts. They're accumulations. What are you accumulating? Well, these are the rates of change in the amount of fuel. The integral of the change in amount of fuel is the amount of fuel, or the accumulated amount of fuel. And so my answer should be how much the tank is losing or gaining potentially. Now, this is a little bit tricky with the negative in there. So, however, because of the fact that, well, actually, because of the fact that from -1 to 2, the whole graph is negative, that actually will work itself out. So going back up to the picture, I'm supposed to use how many? 3 subintervals. Well, that's nice. From -1 to 2, that means each subinterval is simply 1 across. So I think it'd be helpful to sketch this, which they didn't do in the answer key. So to sketch this, that means my first rectangle goes from here to here, and then from over to here, and then over to here. So those are my 3 rectangles. Now what height do I use? Well, if I'm doing a left Riemann sum, then I go to the left side of each of these 3 rectangles. That's then where I draw my rectangle, so it goes over like this one goes over like this, and this one goes over like this. Clearly an overestimate. If I wanted to write it then, I'd say the integral from -1 to 2 is approximately, or the LRAM is approximately the left rectangular approximation method, 3 subinterval, etc., etc., etc. But it's essentially, it's equal to, each one is 1 wide times, so because they all have the same height, I can just take their, or width, I can take their 3 heights, and the first one is the left point, which is -20, and then -15, and then -12. And since that's all negative, I add up negative. That's -47, which is then hundreds of gallons. And to interpret it, between 11 and 2 o'clock, the tank lost about 4,700 gallons of fuel. Now this is clearly an overestimate in the negative direction. It lost less fuel, but that's our LRAM. Okay, and the answer key said very similarly for letter B. When you're interpreting the value, make sure you use the from time to time. Put the, just like at this time, you'd say from 11 to 2, or from t equals -1 to 2. Use the data to evaluate the integral from 4 to or 3 to 4 of f prime. I was going to say that should be impossible to actually evaluate it unless I knew this area here. That seems unlikely. Well, that's actually not what it's asking, because this is not f prime. So to evaluate the integral of f prime, I'm just going to use the fundamental theorem. This is actually a really easy question. I could see it being a little tricky. And so the fundamental theorem says the integral of this to this would simply be the antiderivative of f prime, which is f, and I would evaluate it at the lower and the upper, or I would take the plug in the upper and minus the lower. And then that should be my approximate integral. No, that'd be the actual integral. And then the units of measure, the integral of the change should just be f again. So this would be gallons per hour, which is the units of f. And how do you find f of 3 and f of -3? That's just right off the graph. F of 3, f of negative, so 8.0851 and -24. And so they got -32.797. So, fundamental theorem of calculus. The College Board seems to really love the fundamental theorem of calculus every year, but especially recently. So I think there's good odds that we're going to have to see some of that. The leak temporarily stops at 2 and again at 3.5, and between these times they pumped in 808 gallons of fuel. Write an expression using an integral to figure out how much gallons there are, how much fuel there is at 3.5. Use your answer from part B to get a numerical estimate. Okay. So the integral expression, this is simply the AP exam seems to be heading this route with this same word. I've seen a whole bunch in the review recently. We've already done some like this, but this is simply where I am at 3.5, the rate of change of the fuel, no, the amount of fuel. So I need like super capital F. I don't even know how to do that. Let's do A for amount. The amount of fuel at 3.5 is the only place I started. The only place I know of for sure was at 5,000, and then I add the integral 5,000 goes with -1, and where do I want to end? At 3.5, and what am I taking it? The derivative of a, which is f of t, which really, to do that, I would have to say a equals a prime equals f, or something like that, since I introduced a new variable, if I actually want to use that notation. I don't even have to have this part, though, if I just have this. So 5,000 plus that, and then this integral, I could do this. The integral from -1 to 2 is approximately 4,700, negative 4,700, and now I'm going to add on this 808, and that's going to give me my approximation. So kind of a cool problem. Oh, and the 5,000. I forgot about that. And so theoretically, at 3:30, there were 1,108 gallons of fuel in the tank, and that's that problem.